look at your problem solving, page 9.4. I'm going to show you how to solve these problems so you can use this to double check your work and to make sure that you solved it properly. Nick and Inez are running around a 1-mile loop in the park. Nick runs an 8-minute mile and Inez runs a 10-minute mile. If they start together, how long will it take Nick to pass Inez a second time? So I'm going to kind of picture this here. If they're going to draw a loop around, a 1-mile loop around the park, there's my 1-mile loop, and they both start here. Nick, he runs an 8-minute mile, and Inez runs a 10-minute mile. So if they start at the same time, how long will it take for Nick to pass Inez a second time? I'm just going to solve this problem by using multiples of 8. Well, in this case, just finding the list of multiples. So I'm going to start with Nick's 8-minute mile. So you would have 8, 16, 24, listing my multiples, 32, 40. And Inez runs a 10-minute mile, so that would be 10, 20, 30, 40. They both have 40 in common. That's their least common multiple. So in 40 minutes, since we're talking about minutes, in 40 minutes, Nick will pass Inez the second time. If I wanted to solve this problem using prime factorization, I would solve it like this. I would start with my 8. I'll just put a box around it so you can see what I'm doing here. So I have my 8, and I'm going to use prime factorization. That would be 2 times 4. Break the 4 down to 2 times 2. I'm going to bring down this 2 so I don't forget about it. And then 10, using prime factorization, that would be 2 times 5. Now I'm going to list them here. So let's see, 8, we've got 2 times 2 times 2, and 10, for 10 minutes, 2 times 5. They have a 2 in common, so I'm only going to use that one time. And let's see, so we have 2 times that 2 times 2 times 5, and 2 times 2 is 4, and 4 times this 2 is 8, times this 5, 8 times 5 is 40. 40 minutes. So my prime factorization matches when I list the multiples. Problem number 2. Willis has a guitar lesson every 3 days and a piano lesson every 5 days. How often does he have a guitar and a piano lesson on the same day? That'd be exhausting. So let's see, guitar is every 3 days. So my answer looks like it's going to have to be in days. And piano lesson every 5 days. Now some of you are going to be able to look at this and know the answer right in your head. But let's use list. We're going to list the multiples and see when the first common multiple they have in common. So we go 3, 6, 9, 12, 15, 18. And then let's see, the piano was every 5 days, so we'll list the multiples of 5, 10, 15. So as you can see, listing the multiples, the first smallest unit of multiple that they have in common is 15 days. So the least common multiple is 15. So every 15 days, Willis will have a guitar lesson and a piano lesson on the same day. So now we can figure this out also, if you choose to do it this way, by using prime factorization. So I have, well, this is a real easy one, 3 and 5. So really the only thing you can do is 1 times 3, and 5 would be 1 times 5. And if I list them, multiple or the factors for 3, 1 times 3, and for 5 is 1 times 5. They have the 1 in common. We'd only use that once. So it would be 1 times 3 times this 5 here, and that equals 15. So that's a real easy one to use prime factorization. So every 15 days, Willis will have a guitar and a piano lesson on the same day. For number 3, Anna said the least common multiple of 8 and 12 is 4. 8 and 12. Explain what Anna's mistake was, then tell the correct answer. Well, if I want to find the least common multiple, I'll just do it in prime factorization. 2 times 4 and 2 times 2. I'm going to bring down this 2. And 12 would be 3 times 4. And then 2 times 2, bring down like 3, so I don't forget about that. And I'm going to list them. So 8 would be 2 times 2 times 2, 12. I'm going to list those factors. 3 times 2 times 2. They have 2 in common and another set of 2's in common. So if I'm going to multiply this out now, I'll use that 2 times, we'll use that 2 times that 2 times 3. 2 times 2 is 4, times this 2 is 8, times 3, 8 times 3 is 24. So the least common multiple equals 24. But Anna said the least common multiple was 4. So what did she do? Well, she got a little bit confused, and she actually tried to find the greatest common factor instead. What she did, there's a different color here, she looked at, well, they both have a 2 in common and another 2 in common, and then what she did was she multiplied the 2 times the 2 to come up with the greatest common factor of 4. So she got confused. So she found the greatest common factor instead of the least common multiple. An easy mistake to make. Number 4, this one's a little bit confusing. When can the LCM, the least common multiple of 2 numbers, be one of those numbers? Give an example. So your answer to this, the least common multiple can be one of the 2 numbers when the greater number is a multiple of the lesser number. Well, what does that mean? So if I have a 4 and an 8, if I write the list for these two, I would go 4, 8, 12, 16. And if I'm going to list the multiples of 8, I could do 8, 16. But the LCM happens to be an 8. So what does this mean? If the greater number, which happens to be 8, is a multiple of the lesser number, which happens to be 4, then that would be true, the statement. So here's the 8, and it is a multiple of the lesser number 4. And the last problem, can the LCM and the GCF of 2 numbers be the same number? Explain why or why not. No, they can't. And one way you can try and solve this is by using prime factorization. We'll do 4 and the 8. And the process is similar as far as getting the prime numbers. 4 would be 2 times 2. 8 would be 2 times 4. And break that down into 2 times 2. And I don't want to forget about that too. Okay, let's find out what the greatest common factor is. We'll do that first. Greatest common factor. They each have a 2 in common and a second 2 in common. So then you would multiply what they have in common, 2 times 2, and the greatest common factor would be 4. But how would you find the least common multiple? What would that be? I'm going to line up. Let's see, for 4 I have 2 times 2, and for 8 I have 2 times 2 times 2. They have this 2 in common, which I can use once. They have these 2 2's in common, and then that 2. So, using a lot of color coding here. So let's check this off. This would be 2 times this 2 times this 2. 2 times 2 is 4, and 4 times 2 is 8. So even though you use prime factorization to find the greatest common factor and the least common multiple, when you actually do the final task in figuring these out, it's never ever going to be the same answer.